WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, you are welcome to Eko Learners Support for WAEC and NECO candidates. We are going to continue with our chemical equilibrium. My name is Oluwaleke Animation.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So the learning objectives for this class is this. At the end of the class, the students should be able to explain the effect of pressure on chemical equilibrium. Also, you are going to undergo revision on the effects of change in temperature. Effect of pressure. How does pressure affect a reaction in equilibrium? As we can see, the pressure of a gas is proportional to the number of moles. Increase in the number of moles implies an increase in pressure and vice versa. So if the forward reaction proceeds by decrease in the number of moles and impose increased pressure, we favor the forward reaction. What is this telling us? Yes, an imposed increased pressure, we favor the forward reaction. What does that mean, students? Let's take a reaction like this. Nitrogen plus hydrogen to give us ammonia. So this is the WASSCE process, which we are all familiar with. Looking at it very well, we have total number of moles on the left-hand side as 4. 1 plus 3 is equal to 4. While on the right-hand side, we have 2. So the forward reaction, if you observe very well, leads to reduction in the number of moles. It is moving from 4 to 2. Let's take note that pressure only affects gases. So these are all gases. Nitrogen is a gas, hydrogen is a gas, ammonia is a gas. If any one of them were solid or liquid, you will not add it as part of the number of moles. What do I mean? Let's take, for instance, this hydrogen were to be in a solid form. The total number of moles on this side is going to be just 1. Or this ammonia were to be in a liquid form, the total number of moles on this side will be 0. So I want our students to take note of that. So from the forward reaction involves reduction in the number of moles. So that is what is, we are saying here. An imposed increased pressure will favor the forward reaction. An imposed increased pressure will favor the forward reaction. For decrease in the number of moles. We can represent it like this. Forward reaction is decrease. Backward reaction is increase. So it's only increase in pressure that can favor forward reaction. I believe the students at home are following. Why? Decrease in pressure will favor backward reaction. We have already stated this in lecture Taylor's principle before. So let's continue. The reverse is the case if it proceeds by an increase in the number of moles. In other words, when high pressure is applied, equilibrium will shift to the side with the less number of moles. So that's what we are saying here. So increased pressure, as you can see, we favor the side that have a lesser number of moles, while decreased pressure, we favor the side that have higher number of moles. So let's take some practice questions for us to understand what we have been talking about since on effect of pressure and temperature. This is the question. The production of ammonia by the Haber process goes thus, as you have seen. The production of ammonia will be favored by what? That's what the question is asking us. One of our popular examination questions we are familiar with. The production of ammonia will be favored by what? In our previous classes, we have talked about temperature. So this is just like a recap for us to understand it better. Now, if you look at it very well, what will you think is the answer? Hi, Daniel talking about A. Is it A? Let us all find out if it is A. A says only high pressure. Only high pressure. Okay, let's consider it. We have an exothermic reaction here. Since the delta H is negative, that means in terms of temperature, the forward reaction can only be what? Favored by a decrease in temperature. Remember, we have stated this before, that for an exothermic reaction, we can represent it with I. For an exothermic reaction, we can represent it with what? With I. While endothermic reaction, which is the reverse, is what? Is D. So, to favor the forward reaction, that means increase in what? Production of what? Ammonia. It cannot only be a high pressure. Looking at it, temperature also has what? An effect. So A is not the correct answer. And if you look at pressure, in terms of pressure, we have 1 plus 3 to give us 4. From 4 to give us what? 2. From 4 to give us what? 2. So meaning that the forward reaction in terms of what? Pressure leads to decrease in the number of moles. The forward reaction leads to decrease in the number of what? Moles. While the backward reaction leads to what? Increase in the number of moles. So for me, favor the production of ammonia, high pressure is needed to favor the production of what? Ammonia. But that is not the only thing that is needed to increase the production of what? Ammonia. Can I have another option? Yes, somebody said B, only high temperature. As the word states only, it cannot only be temperature. So it takes a combination of more than temperature for us to favor production of what? Ammonia. Now, I think I heard Kanike at the back said D. That is wonderful. That is wonderful. Now let's all consider Kanike's answer. This is a combination of low temperature and high pressure. A combination of low temperature and high pressure. Let's look at it. This has been conformed to pressure. The forward reaction leads to decrease in pressure. The backward reaction leads to increase in what? In pressure. You agree with me to favor ammonia, to favor the production of ammonia, there need to be a high pressure. To favor the production of ammonia, there need to be a high pressure. So the parts on high pressure has been confirmed. High pressure leads to high quality yield of what? Ammonia. Now, let's consider the second one. Low temperature. As we all know before, this is what? An exothermic what? Reaction. This is an exothermic reaction. The forward reaction is exothermic, which leads to what? Increase in temperature. So it's a low temperature that will what? Favor the forward reaction. Is when we decrease the temperature that forward reaction will be what? Favored. So Kanike got it right. Thumbs up for him and for all others that have what? Tried. So D is our answer. Combination of low temperature and high pressure. I believe we all understand. Let us move to practice question number 2. Practice question number 2. This is the reaction. Is an endothermic what? Reaction. In the reaction above, the forward reaction is favored by. The forward reaction is favored by. Now, what favors the forward reaction? Now let's consider it very well. In terms of temperature, the forward reaction is endothermic. So the only thing that can favor the forward reaction is increase in temperature. Increase in what? Temperature. Increasing the temperature favors the forward reaction because it's an endothermic what? Reaction. So if we look at it in terms of pressure, is there any of the options? Okay, we have pressure there. If you look at it in terms of pressure, there is 0 number of moles on this side. Who can tell us the reason why there is 0 number of moles on this side? Thank you very much, Kamsi. Because we already said that pressure is only applicable to what? Gases. So the number of moles on this side is 0. While the total number of moles on this side is 1. Because we are not going to what? Include this one also. So from 0 to what? 1. So the forward reaction leads to what? An increase in pressure. So to favor that forward reaction, it does not require an increase in pressure again. Instead, it requires a decrease in pressure. So our answer is D. Increasing the temperature favors the forward reaction. I believe we all understand. So that takes us to question number 3. Question number 3. Now let us look at this very well. It combines both pressure and temperature also. In which of the following cases will a decrease in pressure and an increase in temperature shift the equilibrium position to the right? Shift the equilibrium position to the right. Who can tell us another sentence or phrase that can represent that? Yes. Thank you, Chimobi. Shifting the equilibrium position to the right means what will favor the forward reaction. What will favor the forward reaction? Because if you look at the arrows that are pointing to the right, it is the forward reaction that is pointing to. The arrows that are pointing to the left is backward what? Reaction. So in other words, the question is asking us, in which of the following cases will a decrease in pressure and an increase in temperature shift the equilibrium position to the right to favor the forward reaction? Did I hear somebody say A? Okay, let us consider option what? A. This is an endothermic what? Reaction. So the forward reaction, remember, the forward reaction for an endothermic reaction can only be favored by an increase in temperature. The forward reaction for an endothermic reaction can only be favored by an increase in temperature. So that means A has passed one of the tests, increase in temperature. Remember, it takes 2 to tango in this particular question now. A has satisfied increase in temperature. Now let's see whether A will satisfy decrease in pressure. Pressure, in terms of pressure, what are the total number of moles on the right? What are the total number of moles on the left? Don't forget, my students, that it is a liquid that is on the right side. That means we have total number of moles here as what? From 2, total here is 2, while total here is 0. Don't make a mistake and think that it is from 2 to 3. We have already mentioned that for liquid and solid, they don't have any relationship with pressure. So from 2 to 0, what is 2 to 0? 2 to 0 is a decrease in the number of moles. What can favor decrease in the number of moles? Increase in pressure. So A does not satisfy our answer. A does not satisfy our answer because for A is only increase in pressure and increase in temperature that will favor the forward reaction. So which does not agree with what the condition we are given. I heard somebody said B. Is it B? Let us go through it if it is B. B is an exothermic reaction. B is an exothermic reaction. And if you remember, for an exothermic reaction, the forward reaction can only be favored by a decrease in temperature. The forward reaction in an exothermic reaction can only be favored by a decrease in temperature. So which has already nullified one of the conditions, because the condition said increase in temperature. So B does not favor increase in temperature, because it's only a decrease in temperature that will favor the forward what? Reaction. I believe we are all following. So we now know why A and B are not correct. Yes, thank you very much. Kanike. Kanike mentioned that C is the answer. Yes, I agree with Kanike, and you all will agree with him after we analyze it shortly. If you look at C very well, C, number one, is an endothermic what? Reaction. Because we have been told that delta H is what? Positive. It is endothermic. And for an endothermic reaction, remember the forward reaction can only be favored by an increase in temperature. We have said it before. For an endothermic reaction is denoted D for the forward reaction. The reverse reaction is denoted what? I. Whatever will favor the forward reaction is an increase in temperature. Remember our Leclerc's principle. So when you increase the temperature, the system will try to adjust to neutralize or cancel out the effects. So it will now what? Favor the what? Forward what? Reaction. So increase in temperature favors the forward reaction. That's one aspect has been what? Confirmed. Let's confirm the other aspects. For C, how many number of moles do we have on the left hand side? 2. That's good. We have 2 because this is 1. This is 1. 1 plus 1 is what? 2. This is 1. This is 1 here. So total number is what? 2. From 2 going to 3. They are all gases. They are all gases. So it is going from 2 to 3. So from 2 to 3, you agree with me, is an increase. From 2 to 3 is what? Is an increase. So from 2 to 3 is an increase. So let's put I there. From 2 to 3 is an increase. Let me represent the increase. While in the reverse case is what? Is a decrease. 2 to 3 increase. 3 to 2 is decrease. So what will favor the forward reaction? The reason that will favor the forward reaction is for me to decrease the pressure. Decreasing the pressure favors forward reaction. That means we have confirmed the other aspects. So decrease in pressure and an increase in temperature favoring forward reaction is only possible with option C. It's only possible with what? Option what? C. So I believe we all understand this better. Now the fifth one says, what will be the effect of increase in pressure on the following system at equilibrium? What will be the effect of increase in pressure? So there's a mistake there. This should be SO3. What's wrong with my... Okay, so this is SO3. That's a reaction from contact process. So what will be the effect of increase in pressure? Looking at the reaction, they are all gases. They are all gases. They are all gases. So that means the total number of moles on this side is 2 plus 1, which is 3. So it's moving from 3 to 2. So the forward reaction leads to decrease in pressure. The forward reaction leads to decrease in pressure. What does that mean? That means for me to favor forward reaction, I have to increase pressure. So the question says, what will be the effect of increase in pressure? So if I increase the pressure, it will favor the forward reaction. This is the forward reaction. This is the forward reaction. This place, this outer is moving to the what? To the right. So for me to favor the what? Forward reaction, that means there will be what? Increase in what? Pressure. So what should be our answer? Did I hear somebody say B? No, no, no. If you choose B, that means you are favoring the backward what? Reaction. You are favoring the backward what? Reaction. Because we have already agreed that increase in pressure will favor forward what? Reaction. So what we are looking for in the options now is what tallies with favoring forward reaction. As I said in previous lessons, that it can be written in different formats. So one format that is written here now is option A. Look at option A very well. If you look at it very well, you will see that it agrees with forward reaction being favored. Option A says more SO3 will be produced. More SO3 will be what's produced. What can produce more SO3, my students, is when the forward reaction is favored. If backward reaction is favored, that's when we can go for option B. SO3 will decompose faster because backward reaction being favored means SO3 what? We produce SO2 and what? Oxygen. So our answer is option what? A. Our answer is option what? A. Now let's move to the last question. Which of the following reactions will be affected by change in at equilibrium? We also mentioned it, that whenever we are talking about effect of equilibrium, we said that it's only applicable to gases, number one. Now, another factor that affects this pressure is this. The total number of moles of reactants and products on both sides must not be the same. The total number of moles of reactants and products on both sides must not be the same. If they are the same, pressure will not have an effect. If they are the same, pressure will not have an effect. So let's look at the options. The question is which of them will be affected by change in pressure? A, will it be affected by change in pressure? No. Thank you. Because we have 1 plus 1, 2, 1 plus 1, 2. So 2 is on the right side, 2 is on the left side. They are equal, so pressure cannot affect it. Now let's move to B. 1 plus 2, 3. 3 to 2. Remember, students, as you are adding, counting, take note that they are all in gaseous form. The one that is not in gaseous form, you don't count it. So 1 plus 2 is 3. From 3 to what? 2. Yes, this one is unequal. So my answer is D. If you look at C, this is 2, this is 2. If you look at D, this is 2, this is 2. So our obvious answer is what? B. We believe with this, we will all be able to confidently solve any questions on chemical equilibrium.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For any suggestion, comments, or inquiries, please contact the information displayed on the screen. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.